The Big Ear radio telescope stood in a field outside Delaware, Ohio, for 34 years. It was not a dish. Most people imagine radio telescopes as bowl-shaped structures pointing at the sky. The Big Ear was different. It was a flat reflector, a rectangle of wire mesh the size of 3 football fields, tilted to face a fixed point on the horizon. The sky moved above it. The telescope did not. Each point in the sky passed through the Big Ear's field of view exactly once every 24 hours, for exactly 72 seconds. That was the geometry of the instrument. That number, 72, was not arbitrary and not special. It was the transit time. Any celestial source that the Big Ear could detect would appear in its data for 72 seconds and then leave. On the night of August 15th, 1977, the Big Ear was running automatically. No operator was present. The telescope swept across the sky as the Earth rotated, and the data it collected was processed by a computer and printed on continuous paper in columns of alphanumeric characters. Each character represented signal intensity at a given moment. Low intensities were represented by digits. Higher intensities were represented by letters. The blank space, the most common character, represented the noise floor, the ordinary static of the universe. At 10:16 p.m. Eastern Time, the data stream changed. For 72 seconds, the characters coming out of the printer were not digits. They were not blank. They were 6EQUJ5. The intensity had spiked to 30 times above the noise floor and then descended, precisely as a point source passing through a fixed radio beam would be expected to do. Nobody in Ohio saw it happen. Nobody would know until several days later, when a volunteer researcher named Jerry Ehman sat down with the printout, reached for a red pen, circled the sequence, and wrote one word in the margin. The word was wow. That word has not been explained for 48 years. To understand what the wow signal was and why those 72 seconds still matter, you have to understand what scientists were looking for and how they had defined what they were looking for before they found anything. In September 1959, physicists Giuseppe Cocconi and Philip Morrison published a short paper in Nature. The paper asked a question that had not been formally posed in a scientific journal before. If an intelligent civilization elsewhere in the galaxy wanted to send a message to another civilization, what frequency would it use? Their answer was specific. The hydrogen atom, when its electron flips its spin alignment, emits radiation at a frequency of 1420.405 megahertz. This emission, called the hydrogen line or the 21 centimeter line, is the strongest natural radio signal in the universe at that frequency. Hydrogen is the most abundant element in the universe. Any civilization with basic knowledge of physics would know this frequency. If you wanted to send a signal to a stranger and be understood, Cocconi and Morrison argued, you would send it at 1420 megahertz. It was the closest thing to a universal calling frequency that physics could provide. The following year, astronomer Frank Drake pointed a radio telescope in Greenbank, West Virginia, at 2 nearby sun-like stars and listened at 1420 megahertz for several months. He heard nothing unusual. He called the project Ozma, after the queen of a fictional distant land that no one had visited. Drake later developed what became known as the Drake equation, a formula for estimating the number of communicating civilizations in the galaxy at any given time. The result depended on variables that were and largely remain unknown. But the equation gave the search a mathematical framework. It turned a philosophical question into a scientific research program. The Big Ear was built between 1956 and 1961 on a plot of land near the Perkins Observatory, leased from Ohio Wesleyan University. For its first decade, it cataloged radio sources across the sky, an inventory of the known universe in radio wavelengths. In 1973, that work was complete, and the telescope was assigned to the Ohio State University SETI program. It became the longest-running systematic search for extraterrestrial signals in history. The way it worked was simple and slow. The telescope scanned the sky in a grid pattern. Each strip of sky was observed once per day. The data was recorded on magnetic tape, processed by a computer, and printed on paper. Columns of intensity readings, each row a fraction of a second of observation. A team of volunteer researchers read through the printouts by hand, looking for anomalies. The anomalies were rare. Most of what the Big Ear recorded was the steady background of natural radio sources, distant galaxies, pulsars, the diffuse glow of the Milky Way, the occasional blip from a passing satellite, or terrestrial interference. The researchers knew what interference looked like. It was usually messy, broadband, irregular, present across multiple frequencies. A genuine point source from deep space would look different. It would arrive at a specific frequency, peak steadily over the 72 seconds of transit time, and then leave. The rise and fall would follow a predictable curve, the shape of the telescope's own sensitivity pattern projected onto the sky. That is what the researchers were looking for. They had defined it precisely. They had been looking for 12 years without finding it. Jerry Ehman was a part-time researcher at the Big Ear. He had a background in electrical engineering and had worked with the program since the early 1970s. His role was to review the data printouts, pages of alphanumeric output that accumulated in stacks and required patient, methodical reading. On an unrecorded date in late August 1977, the exact day is not preserved, Ehman sat down with the printout from the night of August 15th and began reading through the columns. The data from that night looked like all the other data: strings of blanks, occasional low digits, the ordinary noise of the universe in print form. Then, in one column at a timestamp corresponding to 22:16 and 12 seconds, local time, the sequence changed. The characters were 6EQUJ5. In the Big Ear's intensity coding system, digits represented intensities from 1 to 9 times above the noise floor. Letters represented higher values. A was 10, B was 11, continuing up the alphabet. U, the fourth character in the sequence, represented an intensity 30 times above the noise floor. Ehman looked at the numbers, then he looked at the shape. The sequence ascended. 6EQU reached its peak and then descended. J5. The curve was Gaussian. It was the exact shape you would expect from a point source transiting through the Big Ear's beam. He checked the frequency, 1420.356 megahertz. The hydrogen line is at 1420.405 megahertz. The difference, 0.049 megahertz, was consistent with a Doppler shift caused by the relative motion of a transmitting source and the Earth. Not an exact match, a physically plausible near match. He checked the bandwidth. The signal occupied a very narrow slice of the spectrum, narrower than any known natural astrophysical emission at that frequency. Natural sources emit across broad bands of frequencies. Artificial transmitters, by design, emit in narrow bands to concentrate their power. This signal was narrow. He checked the source direction. The signal had arrived from the direction of the constellation Sagittarius, near the star group Chi Sagittarii. No known transmitter was in that direction. No satellite was cataloged there. No known natural source of that intensity existed at that location. Ehman circled the 6 characters with a red pen. In the margin beside them, he wrote the word that would name the event for the next 50 years. Wow. He reported the finding to the program's director, John Krause. The observation was checked and confirmed. The data was real. The printout was not an artifact of the equipment. Something had arrived at 1420 megahertz from the direction of Sagittarius on August 15, 1977, at peak intensity 30 times above the noise floor for exactly 72 seconds. The search that followed was systematic. In the weeks after the discovery, the Big Ear returned to the same part of the sky on every available observation cycle. The sector was watched closely. Other radio observatories were informed. The Very Large Array in New Mexico, still under construction but with operational components, observed the region. The Arecibo Observatory in Puerto Rico pointed its enormous dish at Sagittarius. None of them detected the signal again. The WOW signal was observed once for 72 seconds and never again. The scientific response to the WOW signal was not to declare it evidence of extraterrestrial intelligence. It was to search for alternative explanations and to acknowledge that, without a second detection, no conclusion was possible. The most persistent alternative explanation was also the most mundane: terrestrial interference. Radio frequency interference from satellites, aircraft, military transmitters, or industrial sources was the most common cause of anomalies in radio telescope data. But the WOW signal's characteristics were difficult to reconcile with known interference sources. Its narrow bandwidth was inconsistent with common radio frequency interference. Its arrival direction was not matched by any catalog transmitter. The Gaussian transit profile, the smooth rise and fall, was the opposite of the irregular spikes that typically characterized interference. A more significant alternative arrived in 2017, nearly 4 decades after the event. Professor Antonio Paris of St. Petersburg College in Florida proposed that the WOW signal had been emitted by hydrogen gas surrounding one or both of 2 comets that were passing through the same region of sky in August 1977, Comet 266P Christensen and Comet P2008Y2, also known as Gibbs. Comets release hydrogen as they sublimate. The hydrogen forms an extended cloud around the comet nucleus. That cloud emits at approximately 1420 megahertz. The hypothesis was published and received attention. Jerry Ehman responded with detailed objections. The comet's hydrogen clouds, he argued, would emit at a much wider bandwidth than the WOW signal's extremely narrow profile. The comets would have been continuously visible in the Big Ear's scan pattern for days before and after August 15th, but no signal was detected on adjacent observation nights. The hypothesis, he concluded, did not explain the specific properties of what was recorded. The debate was published. Neither side was definitively confirmed. The WOW signal remained unexplained. The deeper difficulty was not theoretical, it was physical. The Big Ear had been sold. In 1982, Ohio State University sold the land rights to a developer who planned a golf course and residential community. For 15 years, while astronomers continued working with the telescope and debating the WOW signal, the land beneath it was legally committed to development. In 1997, the university declined to renew its lease. The Big Ear was decommissioned. The telescope was physically demolished. The flat reflector dismantled, the support structures removed. The cables were cut. The equipment was sold for scrap or sent to storage. The land was developed as planned. The Beckett Ridge neighborhood of Delaware, Ohio, was built on the site. Houses, roads, a community of approximately 1,200 homes. The golf course was built on the western portion of the former telescope site. The fairway of one of its holes passes across the exact coordinates where the Big Ear once stood. John Krause, who had designed the Big Ear, and directed the Ohio State SETI program for decades, died in 2004. He did not learn the origin of the signal he had spent 30 years looking for. The consequence of the demolition was not merely sentimental. The Big Ear had a specific combination of characteristics, its geometry, its location, its scan pattern, that could not easily be replicated by other instruments. More importantly, no other telescope had been systematically observing that sector of sky at 1420 megahertz, with the same sensitivity over the same time period. A second detection would require a sustained program of observation with a comparable instrument at the same frequency. After 1997, no such instrument existed in that configuration. The WOW signal could not be confirmed. It could not be reproduced. The instrument that recorded it was gone. What remains is a question about the architecture of knowledge. The scientists of the SETI program had done something methodologically rigorous before the WOW signal arrived. They had defined in advance what they were looking for: narrow bandwidth, proximity to 1420 megahertz, Gaussian transit profile consistent with a point source, intensity significantly above the noise floor, direction from deep space rather than local interference. They had set up the definition. They had been watching. On August 15, 1977, something satisfied every criterion of the definition. The satisfaction was complete and simultaneous. The signal did not partially match. It matched across every parameter that had been specified. And then it did not come back. The consequence of a signal that matches the definition but doesn't return is a permanent suspended state. You cannot conclude it was extraterrestrial because you cannot verify it. You cannot conclude it was natural because no natural explanation has been confirmed. You cannot conclude it was instrumentation error because the data is real and has been independently verified. The WOW signal does not sit in any of the categories that science uses to file things away. It sits in a category that science has no good procedure for, a single unrepeated event that was exactly what you were looking for. The printout from August 15th is preserved. The original paper with Ehman's handwriting still visible is in the Ohio State University archives. The 6 characters and the word beside them are as clear as they were in August 1977. The paper has not changed. The sky has not changed either. There is a golf course in Delaware, Ohio. It is a standard American municipal golf course. Greens, fairways, a clubhouse. The grass is cut to regulation length. The sprinklers run on a schedule. On weekends, people walk the course with carts and carry their scores on small printed cards. The fairway of the 4th hole passes through the coordinates where the Big Ear once stood. The sector of sky that the Big Ear observed on August 15, 1977, the part of Sagittarius from which the signal arrived, is still there. It is visible from Delaware, Ohio on any clear summer night. Any radio telescope with sufficient sensitivity pointed at those coordinates could listen at 1420 megahertz. The Breakthrough Listen Initiative has done so. The SETI Institute has done so. Several other programs have listened. The signal lasted 72 seconds. The telescope that recorded it stood for 34 years. The fairway has been there since 1998. In the direction of Sagittarius, the sky is unchanged. The signal has not returned.